right, so here we're going to recreate the chart. So we start with the number 1.
Yep.
All right, where does 1 come from?
1 has to come from 2.
All right. 1 has to come from 2. Where does 2 come from?
2 could come, it has to come from 4.
2 comes from 4. Huh?
4 comes from 8.
4 comes from 8.
I suppose 4 could come from 1 also, but that's just the repeating cycle.
That doesn't work because once you reach 1, you've stopped.
Oh no, he's got a very good point.
The 1, 2, 4, 1.
Yeah, the multiply by 3 plus 1. Oh, multiply by 3 plus 1 connects 4
to 1.
to 1, but their rule was multiply by 3, add 1, and divide by 2, which connects 1 to 2.
Which you've done.
Which we already did. But it was a good idea that 4 comes from the multiply by 3, add 1. Maybe that gives a different tree, actually. Maybe a slightly different tree. All right, what about 8? Where does 8 come from?
8 can come from 5, actually. Or it can come from 16.
Ah, okay. So maybe I'm going to redraw. I'm going to go 1, 2, 4, 8. Like this. 1, 2, 4, 8. And then, yeah, it came from either 16, but it also came from 5 under this rule. Multiply by 3, add 1, divide by 2.
Yeah.
All right. What about 5 then? Where can 5 come from?
5 can come from 3. Because 3 times 3 is 9 plus 1 over 2.
Uh-huh. So it can come from 3?
Or it could come from 10.
Yep.
Or it can come from 10. Interesting.
16 can come from either 32 or well, just 32 actually.
Oh, okay. Why?
Because the times 3 plus 1 over 2 doesn't work because when you so 3x plus 1 would have to equal 32.
Uh-huh.
So 3x would have to equal 31, but no integer does that. 31 is indivisible by 3.
Ah, okay. Good. What about 3? Where does 3 come from?
So 3 could come from 6.
Yeah. I guess.
Or, just 6.
Yeah, 6.
All right. Why don't you tell me about 10?
10 can come from, I think just 20.
Just 20. Okay. All right. So we've got, let's find one that maybe branches. Yeah, I think 20 branches. Can you tell me the branches on 20?
20 can come from 40.
Right.
Or it can come from 13.
Ah, or it can come from 13. So you start getting this very interesting tree.
Yeah.
And in the video they made a really terrific
Tree.
and they colored it in. It was really cool.
It was all the numbers less than, I think, 10,000.
Yeah, and it'd be fun to try to recreate this and see, because it looked like they had branches going over and under, and
Yeah.
do you think any of the branches ever reconnect once they diverge from each other?
They could.
Well, that actually might be a loop. Or that would be a number that would work
Oh.
for the conjecture.
Huh, I didn't think about that. Maybe if they connected, maybe that would lead to a loop.
And then that means you had just disproved the Collette's conjecture.
6 hypothetically connected back to 20. It would just go in this loop.
Well, I don't know if it would.
I don't know, actually.
I don't know. Because you can always go down the tree, but maybe reconnecting branches would.
Result in
Maybe
a loop.
it would. So yeah, so it's interesting to think about the Collette's conjecture in this format. All right, for the last video, let's just pick a number and play it out and see what happens. Okay.
Okay.